got to understand that that ship, each and every day, is affected by the elements.
Corrosion is the #1 problem in the fleet today. Every ship can benefit from corrosion control.
Corrosion control now will pay dividends in the future.
The Navy has been dealing with corrosion as long as there's been a Navy. A ship deteriorates if it is not maintained. We cannot permit corrosion to impede our readiness and our availability of our ships.
Achieving expected ship service life is vital to sustaining our fleet. The Corrosion Control Program for surface ships has been established to effectively address corrosion challenges during acquisition and throughout its service life. To ensure a multidisciplined and comprehensive approach, a corrosion control knowledge sharing network has been implemented within the Navy.
The primary purpose of the Corrosion Control KSN is to enable sailors. It's to preserve ships. What it is specific guidance, technology, processes, practices that we equip our waterfront activities with and our ship's crews to expedite the fight on corrosion and give them the tools, the methods necessary to do it in the most economical manner possible. What makes the KSN so valuable, when you select a task and form up a team under the KSN, now you have every aspect, people from every walk of life concentrated on one problem. So it's no longer simply a technical or engineering problem, it's also a maintenance scheduling issue. There's aspects of it that are very pervasive throughout the command.
Sharing knowledge across disciplines within the Corrosion Control Network is important to the program's success. At the Naval Research Lab in Key West, for example, research and development of various marine materials are tested and evaluated. Results are shared within the fleet.
We have a couple of really good success stories, one being our corrosion sensors. We put a vertical array of reference cells inside a ballast tank, and external to the tank we can get a good understanding of if the tank is corroding and if we need to send an inspector in there to see the condition of the tank. When we know that the tank is in good condition from these corrosion sensors, it prevents us from putting a manned entry into the tank, and that saves the Navy a lot of money. We're working with the fleet and the regional maintenance centers to get these corrosion sensors implemented across the fleet.
The lab also houses a physical scale modeling facility where every class of vessel in the U.S. fleet is replicated to scale for testing.
It's one of a kind. It's the only facility in the world that uses the physical scale modeling methodology to design and optimize impressed current cathodic protection systems for the United States Navy.
The Impressed Current Cathodic Protection System, or ICCP, is a technique used to mitigate corrosion of a metal surface by strategically placing components, whether they be anodes or controlling reference cells, on the hull of a ship, and controlling the electromagnetic field so that the corrosion process will take place there before damaging the hull itself.
We iteratively model the ICCP component placement on the hull and optimize the positioning of those components. And that's what we deliver as a recommendation to NAVSEA. By actually implementing this methodology, this design process, we can be reassured that when that boat comes into dry dock after she's been out for 7 years, we are not going to have, assuming and operating an ICCP system, we will not have any type of structural or mechanical failures of the external hull due to corrosion.
And it's not only the hull that needs to be monitored and maintained.
The Corrosion Control product family here at Southwest Regional Maintenance Center supports these ships and all the fleet assets. Any metal part that can be removed from the ship, no matter what size. The primary process here is powder coating. So our steps are we receive the items from the ship, we'll then blast off the previous coatings, and we'll preheat the items, powder coat them, cure them, QA them, and then put them in the finished goods ready for delivery to the ship. We process up to 100 parts a day, up to 3,000 a month. I mean, it varies depending on the amount of ships that are in availability and the number of ships that can remove the items.
Mitigating corrosion is a constant process, and corrosion control assistance teams, or CCAT, are tasked with providing technical expertise, tools, and training on board ships.
CCAT's mission is to come on board the ship, train the sailors properly on fighting corrosion, providing them the best tools on the market to mitigate the corrosion, which is a very big issue for their mission state of readiness and for the ship to meet their expected service life.
CCAT has been great so far. We have used them for additional tools, materials. They're also for their guidance and teaching our sailors, proper techniques to improve their abilities and how they fight corrosion.
Continuing to support sailors in their day-to-day battle with corrosion is key to meeting the ship's service life.
Taking care of corrosion is one of the hardest jobs, but you have to stay on top of it. It's rewarding when you actually see it pay off.
We were working on preserving the space. There's some rust and corrosion, so we were trying to get rid of it so that we can paint over it. Definitely stay ahead of the corrosion. Don't slack off.
The United States Navy needs to make corrosion control a way of life. Whether you're a developer, a designer, a maintainer, an operator, that needs to be inherent in your day-to-day work ethic. If we expect to get these ships to sea and keep them at sea, corrosion control needs to be your mantra.